Hello, so I'm just back from NCTM 2017 where I met Ashley Black and we talked a bit about graspable math and about quadratic equations, and she showed me one neat way of solving for the factors or the roots of a quadratic equation by chunking. So here's a little exploration of how you could actually do chunking in graspable math. And we're starting here with the roots already separated. We have factored this. But let's put this together here, and this is the state you'd probably give to a student. Well, you would hide this one. This would be what you want them to come up with. And chunking works in a way that we want to bring this into a form where we can substitute another variable in to make our task a little simpler. So in this case, what we want to do is multiply this whole thing by 15, which is the coefficient in front of the x squared. So what I'll do to do this is I'll take this whole thing and multiply it actually by 15 divided by 15 to keep this equivalent. And I'll now just move this 15 into the brackets. And graspable math is a little bit too eager here. Actually, I want to keep it like this without automatically combining it. So this was 15 times 7 actually. Right, so this is the form I'd like to have. And I'll move this over here. And you see that if I pull the squared out, I have 15x here and 15x here. And we'll now replace this. So 15x, that's the chunking part. Right? So this is our chunk now, and we call that chunk f. I'll substitute that in. So now we have f squared minus 7x minus 30. And this is an easier form because we don't have a coefficient in front of our initial squared term here. And we can think about this in this way here. We can say, well, we want to express that part as two factors, which look like this. And our goal is now to find our a and b, and the way we can do this is we can realize that actually the sum of a and b, that's our coefficient here, the -7, and the -30 back here, that's our a times b. So we have a plus b equals -7, and we also have a times b equals -30. And now, at least when we assume that our teacher picked some nice initial values, we can factor this number here and see if we can come up with two factors which give us this sum. And in this case, like, one of the things which immediately comes to mind is -3 and 10, which doesn't quite work out, but if we do 10 and -10, 3 and -10, then that actually adds up to -7, and it's exactly the thing we were looking for. So that means we can now rewrite this here as f minus 10 times f plus 3. And what that buys us is that we actually now have this in a factored form, and we only need to get back to our original f. So I'm gonna substitute our 15x back in here, and I see now that I can split this up into 3 times 5 and move this one in here, move this one in here. I'll pull that out and simplify a little our fractions here and actually get back to the original factoring here. So we found the roots of our quadratic equation. And so one of the neat things is that this always works if you can guess your numbers down here, that is. And you could also go through, like, you could put A, B, C, D in here and convince yourself that this always works. Okay, so this is how chunking works in graspable math right now. And I'm really curious what you think about this. Can you see this as a good lesson a teacher can give in front of a class? Or maybe it's more suited for student activity? Let me know what you're thinking.